That sound is metal flying apart at 60,000 revolutions per minute. It is the sound of a uranium enrichment centrifuge tearing itself to pieces. 8 meters below the central Iranian desert. What you are about to hear didn't happen because of a missile. It didn't happen because of a bomb. It happened because of 1.5 megabytes of code, smaller than a song on your phone, that walked through the front door of the most heavily fortified nuclear facility on Earth. In the architecture of cybersecurity, the ultimate defense mechanism is called an air gap. If you have a server storing the world's most dangerous secrets, or a computer controlling a volatile nuclear reactor, you don't secure it with a firewall, you secure it with physics. You completely sever the machine from the internet. You remove the wireless, you cut the Ethernet cables. You bury the facility 8 meters underground behind reinforced concrete and anti-aircraft guns. You create a physical moat. By 2008, the Iranian nuclear enrichment facility at Natanz was the most heavily air-gapped environment on Earth. The computers spinning the uranium centrifuges were entirely blind to the outside world. To intelligence agencies in Washington and Tel Aviv, it was an impenetrable vault. You could not hack Natanz from a keyboard in Maryland. To destroy the facility, the United States and Israel had to do something that had never been done before. They had to build a digital weapon, and they had to walk it through the front door. They engineered a piece of malicious code so sophisticated that it didn't just steal data. It crossed the barrier from the digital world into the physical one. It stalked the facility, it hijacked the machinery. It physically shattered the centrifuges from the inside out, all while playing a tape loop of perfect operational data to the engineers sitting at the control desks. It was the first true cyber-kinetic weapon in human history. This is File 05, the Natanz Airgap. In the mid-2000s, the United States and Israel faced a geopolitical nightmare. Intelligence indicated that Iran was rapidly spinning up gas centrifuges to enrich uranium, beyond the threshold of civilian use. A conventional military airstrike on the underground Natanz facility would almost certainly spark a regional war. The diplomatic options had stalled. Instead, the Bush administration, and later the Obama administration, authorized a highly classified cyber warfare campaign, codenamed Operation Olympic Games. The objective was to build a computer worm, eventually known to the public as Stuxnet. But Stuxnet was not a normal virus. At just over 1.5 megabytes, it was smaller than a single song on your phone. And inside that 1.5 megabytes, the engineers at the National Security Agency and Israel's Unit 8200 packed the most advanced, most expensive malicious code ever written. It exploited 4 separate zero-day vulnerabilities. A zero-day is a flaw in an operating system that the manufacturer doesn't know exists. In 2008, a single zero-day was worth roughly $250,000 on the black market. Most weaponized cyber tools used 1, some used 2. Stuxnet burned 4 of them simultaneously just to give itself room to move around. But because Natanz was air-gapped, the NSA and Unit 8200 couldn't just email Stuxnet to the control room. They had to rely on human error. Specifically, they had to rely on a single ordinary engineer carrying a USB drive across the moat. Intelligence operatives identified 5 outside engineering firms that held maintenance contracts at Natanz. They infected those companies' networks. The worm was designed to be hyper-aggressive but completely silent. It did not require the user to open a file or click an icon. Because of the LNK shortcut zero-day exploit, simply viewing the USB drive in a Windows folder was enough to execute the payload. The math played out. Eventually, an unwitting engineer carried an infected USB drive or a compromised maintenance laptop down into the subterranean halls of Natanz and plugged it into the internal network. The electronic moat was breached. He never knew. But Stuxnet didn't attack immediately. It was a digital assassin looking for a very specific face in the crowd. It ignored standard desktop computers. It ignored email servers. It slithered through the local area network, searching for only one thing: Siemens Step 7 software. Step 7 was the interface the Iranian engineers used to program the industrial controllers. The programmable logic controllers, or PLCs, that physically operated the centrifuges. The PLCs were the brainstem of the facility. They told the motors how fast to spin. They controlled the gas pressure. They watched the safety sensors. Once Stuxnet found the Siemens controllers, it installed a rootkit deep inside the system. It took complete control of the facility's physical machinery. And then, it just watched. Before you can break a highly complex piece of industrial machinery, you have to understand how it breathes. Stuxnet did not execute its destructive payload the moment it seized the programmable logic controllers. Instead, it sat dormant in the Natanz control systems for nearly 2 weeks. 13 days. It operated purely in a reconnaissance mode. It recorded the exact baseline frequencies of the centrifuges. It mapped the normal operating pressures of the uranium hexafluoride gas. It memorized what the plant looked like when everything was running perfectly. The uranium centrifuges at Natanz were delicate, incredibly precise pieces of engineering. They consisted of tall, thin aluminum rotors spinning at phenomenal speeds, roughly 1,064 Hz, or over 60,000 revolutions per minute. At that speed, the rotors had to remain perfectly balanced. Even the slightest vibration, the slightest imbalance, would cause the thin metal walls to buckle, tearing the machine apart in a catastrophic failure. Stuxnet had 13 days to learn that physics. Once the worm had recorded its baseline telemetry, the Logic Hijack began. Without warning, the malicious code injected its own parameters into the Siemens controllers. It commanded the centrifuges to radically alter their speeds. First, it spun the rotors up to 1410 Hz, pushing the physical limits of the aluminum far beyond its safe operating threshold, causing massive internal stress. Then, 20 minutes later, Stuxnet slammed the brakes. It commanded the frequency converters to drop the speed from over 1,000 Hz down to just 2 Hz. The centrifuges violently decelerated. The physical stress of the rapid speed-up and the sudden dragging halt began to warp the rotors. The delicate machines began to wobble. They began to strike their outer casings. They began to physically shatter. But as the machinery in the cascade halls began to tear itself apart, the engineers sitting in the control room didn't hit the emergency kill switch. They didn't do anything at all. Because according to their screens, the facility was running flawlessly. In standard cyber attacks, the victim realizes they've been breached when their screen goes black or an alarm sounds. Stuxnet was far more elegant and far more terrifying. It utilized a technique known as a man-in-the-middle attack, executed at the hardware level. As the malicious code commanded the centrifuges to violently oscillate their speeds and destroy themselves, the physical safety sensors in the plant tried to scream for help. They sent frantic error codes back through the network, begging the automated systems to shut down the gas valves and hit the emergency stop. But Stuxnet intercepted those signals before they ever reached the engineers. The Stuxnet rootkit took the 13 days of perfect operational telemetry it had recorded during its reconnaissance phase, and it played it back to the control room monitors on a continuous loop. It was the digital equivalent of a bank robber splicing a pre-recorded tape into the security camera feed. The Iranian engineers sat at their desks, looking at pristine green lights and perfect graphs, completely unaware that hundreds of feet away, the cascade halls were literally shaking themselves to pieces. The first thing the engineers noticed was not the alarms. It was a faint vibration traveling through the building structure. It was the sound of porcelain rattling against porcelain. By the time the technicians on the floor realized what was happening and radioed the control room, it was too late. the damage was done. The engineers ripped out cables and blindly attempted to rewrite the controller code. But the Stuxnet rootkit hid itself perfectly. When they searched the Siemens software for anomalies, the code showed them nothing. No errors, no anomalies, no malicious processes. Just perfect green readings and the distant muffled sound of their nuclear program tearing itself apart. The Olympic Games operation was a staggering kinetic success. Over the course of months, Stuxnet systematically destroyed nearly 1,000 centrifuges. It set Iran's nuclear enrichment capabilities back by an estimated 18 months. The most precise, invisible sabotage in modern military history. The Iranians did not even know they had been attacked by code. They believed, for months, that the centrifuges were failing because of poor manufacturing, or contaminated raw materials, or human sabotage on the plant floor. The United States and Israel had successfully executed a digital strike that no one in the world knew was a strike, until the weapon escaped. Stuxnet was engineered with strict targeting parameters. It was designed to only execute its physical payload. If it detected the very specific customized layout of the Siemens controllers at the Natanz facility, if it landed on any other computer, it was supposed to remain dormant. A surgical strike, a ghost. But a weapon that replicates itself automatically is a weapon you cannot fully control. In the summer of 2010, an engineer left the Natanz facility. He was tired. He drove home through the desert at sunset. He took his maintenance laptop with him. He sat down in his home office. He plugged the Ethernet cable into the side of that laptop, and he connected it to the public internet. He had no idea. The Stuxnet code, due to a programming error in how it tracked its own environment, failed to recognize that it was now outside Natanz. It aggressively reached out to the global internet. The worm escaped. Within weeks, Stuxnet exploded across the planet. It propagated wildly, infecting over 100,000 computers in Indonesia, India, Pakistan, Iran itself, Europe, and the United States. It didn't destroy those computers. It was still hunting for the specific Natanz centrifuges. And on every other machine, it just sat dormant. But its sheer presence set off alarms across the global cybersecurity industry. A researcher named Sergei Ulasen, working for a small antivirus company in Belarus called Virus Blockada, was one of the first to capture a sample of the worm. He was 28 years old. He spent days reading the code. The deeper he read, the more horrified he became. This wasn't a teenager in a basement trying to steal credit card numbers. The code was gigantic. It contained an unheard-of 40-day exploits, burning $1 million of black market value just to give itself room to move. It carried valid digital certificates stolen from real semiconductor companies in Taiwan to bypass Windows security checks. It was a digital cruise missile, based on a file path discovered buried inside the code, which contained the word Stuxnet. The global IT community named the virus. Within months, independent researchers at Symantec, at Kaspersky, in labs across the United States and Russia, reverse-engineered the entire payload. They mapped its target to the Siemens Step 7 controllers. They mapped its frequency overrides. They realized it was custom-built to destroy the centrifuges at Natanz. The United States and Israel had never intended for the world to see the weapon. But the code had leaked, and the secret of Operation Olympic Games was now permanently burned into the public record. The blueprint for the world's first cyber-kinetic weapon was no longer a state secret. It was a public file. When the cybersecurity community exposed Stuxnet, they did not just expose a covert operation. They exposed a permanent paradigm shift in modern warfare. Before Stuxnet, the worst a computer virus could do was delete your files, crash your server, or steal your data. Cyber warfare was entirely confined to the digital realm. Stuxnet proved that computer code could cross the air gap. It proved that ones and zeros could be weaponized to physically destroy concrete and steel. The Stuxnet code is now in the wild. It has been endlessly dissected, reverse-engineered, and studied by hostile intelligence agencies around the world. Its descendants are already operating. In 2016, a worm called Indestroyer brought down a section of the Ukrainian power grid for an hour. In 2017, a worm called Triton was caught inside a Saudi petrochemical plant. Engineers later concluded it was attempting to disable the safety system before triggering a physical explosion. The architectural blueprint that the United States and Israel built in secret in 2008 is now public knowledge. It is being copied, refined, and redeployed. Operation Olympic Games opened Pandora's box. The agencies that built Stuxnet built it to stop a nuclear threat. They succeeded. But in the process, they proved to every government, to every adversary, to every criminal organization with sufficient resources, that the physical infrastructure holding modern society together, the power grids, the water systems, the rail networks, the gas pipelines, is only as strong as the code telling it what to do. The session is logged. The connection is closed. The files remain open,